Okay, so we have a question about number 16 in section 8.6. Okay, so all right, let me share my browser window. Number 16 in section 8.6. Try to close some tabs here to make my computer run smoother. Okay, number 16. Here we have a problem where we have to solve an equation involving a radical, and right, and if the answer doesn't exist, we just write does not exist. Okay. I think this is what we talked about last week, before the last class. So here we have to solve this equation. Let me write it down, and then we can look at it by hand. Okay, so I will take this to the paper, and we'll take a look at this. Okay, so here we have it. It's a radical equation, they call this, because it has a radical, a cubed root. And we want to solve this. So the first thing you want to do when you solve radical equations is you want to, okay, two people are asking about this. I hope the problem's okay. You want to isolate the radical, all right? You want this radical all by itself, okay? So the first step is to get rid of the -3 and the 10. Now, so you have the choice, add 3 first or divide by 10. Well, if you divide by 10, you'll have to divide the 3 by 10. You'll get 3/10, and then you get fractions, and that's probably not a good thing to, that's probably not ideal. So let's add 3 first, all right? Generally, you want to take care of the adding and subtracting parts first. Oh, I don't know what I was thinking. Okay, so there we have it. 10 times the cubed root of x plus 6 equals 50. And then we'll divide by 10. And here we have cubed root of x plus 6 equals 5. So when we get to this point, we've got the radical isolated on one side of the equation. Now we can use the fact that, well, we can just cube both sides, right? If you take the cube root of something and cube it, you just get that something back. So what we'll do now is we'll cube both sides. So cube root of x plus 6 cubed is x plus 6. 5 cubed, that's 5 times 5 times 5. That's 125. Okay. And then finally, we'll subtract 6 from both sides. X equals 119. All right. And then we should check our answer. So if you plug that back in here, 119 plus 6 is 125. The cube root of 125 is 5. 5 times 10 is 50. 50 plus -3 is 47. So it checks out. So that should be all we need to do for that problem. Since 2 people asked me about it, let me just check the problem, make sure it's working okay. Yeah, my OpenMath accepted that answer, so it looks like everything's fine. Oh, and then we have a question. Oh, I see. The next question was about number 18. All right, so let's go to that problem. Let's take a look at it. Number 18 here. Solve the following equation. Okay, so let me write this one down. Oh, where's is my right mouse button not working? Okay. So here we have it. We have radicals on both sides of the equal sign. Okay, so for a problem like this, you want to isolate one of them and then square both sides. If there were cubed roots, we'd cube both sides. Fourth roots, we'd raise each side to the power 4. It's already isolated on one side. We've already got a radical isolated on one side, so that part is done. So what I'll do is I'll square both sides. So we're squaring both sides. On the left-hand side, when you square this, you're going to get root x plus 4 times root x plus 4. That's just x plus 4. Plus root x plus 4 times 3. Plus 3 times, plus 3 times root x plus 4. Plus 3 times 3. So just to be clear, I'm using the formula here. When you square a plus b, you get a squared plus 2ab plus b squared. All right. Here we have a squared. That's what happens when you square this. 2ab, that's 3 times x plus 4. Well, here's one of them. Here's the other one that makes 2. And then plus, oops, this squared. Good thing I checked that. That should be 9. 3 squared is 9. All right, on the right-hand side, we're squaring this. So that's just x plus 22. Okay. So now I want to isolate these radicals. All right, well, I can combine these. All right, so this is x plus 4 plus 6 root x plus 4 equals x plus 22. Just combining these two terms. And then I can subtract x from both sides. Then I can subtract 4 from both sides. You can ignore my calculus work down there. Then I'll divide both sides by 6. Let's bring that over here. All right. So now we have root x plus 4 equals 18 divided by 6 is 3. All right, so now we still have a radical left, so we can square again. So you square both sides. Subtract 4 from both sides. And there we have the answer. We should check it just to be sure, right? When you go back to the original problem here, 5 plus 4 square root is 3. 3 plus 3 is 6. 6 squared is 36. So on the left-hand side, I'm getting 36. Let's see if that's what I get on the right-hand side. Wait, did that work? Doesn't look like it's working, is it? Hold on. Yeah, that's like my check is not working out. Maybe we made a mistake. Because when I plug this in on the other side, I get 5 plus 22, that's 27. Square root of 27. Okay. The original problem didn't have these squares in it, for one thing. Okay, so I shouldn't be doing that. When I plug it on the left-hand side, I get 5 plus 4 is 9. Square root of 9 is 3. 3 plus 3 is 6. So on the left-hand side, I get 6. To plug it on the right-hand side, I'm not getting 6. So something's wrong here. Let's see if I can see what we may have done wrong, or if this answer just does not exist. Let's see. Certainly isn't working. Could just be that there's no answer to this one. Let's see. Let's see. I see. I lost the 9. Okay. Good thing we did that check. See this? I didn't write it on the next line. I forgot to write it. All right. So let's do this. 4 plus 9 is 13. All right. So instead of a 4 here, we'll write a 13. All right. So instead of 4 here, we would have had 13. And I would have subtracted 13 from both sides. Okay. So instead of 22 minus 4 gave me 18, I would have had 22 minus 13 gives me 9. All right. So when I divide both sides by 6, I get 9/6. That simplifies to 3 halves. All right. 9 divided by 6 simplifies to 3 halves, which when I square both sides gives me 9/4. Okay. So 9/4 minus 4, what's that? Well, let's see. 4 is 16/4. So 9/4 minus 16/4 is 7, negative 7/4. Right. So let's see if that one works in here. If I took negative 7/4 and added 4, I would have, well, remember 4 is 16/4. So 16/4 minus 7/4 is 9/4. The square root is 3 halves. So I have 3 halves plus 3. 3 halves plus 3 is 3 halves plus 6 halves. So that's 9 halves. So on the left-hand side, if I ignore the squares, because that wasn't in the original problem, I have 9 halves. If I put it in on the right-hand side, I've got negative 7/4 plus 22. All right, well, 22 is the same thing as 88/4. 88/4 minus 7/4 is 81/4. All right, so this is the square root of 81/4. Square root of 81 is 9, and the square root of 4 is 2, so it's 9 halves. So I think I got the same thing on both sides, so that checks out. Right. And I'll go ahead and check that in my open math, and yes, it accepted my answer. So, all right. That is the importance of checking your work, right? Because if we didn't check it, we may have put in the wrong thing, right? So, but the point here is that you isolate one of the radicals, and then you square or cube or raise to the 4th power each side, depending on the index of the radical, and then you simplify, and then you get the other radical isolated, and then you do it again, right? So it's a kind of a 2-step process here. Okay. Any other questions? Nope, not seeing anything. Okay. So, just a reminder, in case you came in a little late, the exam is the Thursday of, not this week, but next week. It's Thursday, April 30th, all right? And it covers chapters 8 and 9. And there will be a couple problems on there where I want you to show your work, and that'll be worth a substantial amount, more than it was in the last exam. Last exam, it was only worth a few points because I wasn't sure how it was going to work out. So look at your exams and look at how I graded the last one. I gave you some comments, so make sure you look over those. But keep in mind that on the next exam, the work that you show is going to be worth more points. So it's important that you be able to do that right. Okay. And okay, so let's talk about the new material. New material we're going to cover today is using the quadratic formula and then solving application problems. Okay, so we learned about the quadratic formula last time. This was section we talked about completing the square, and that was section 9.2. We used completing the square to derive the quadratic formula, which brings us to section 9.3. Okay, so let me go down to the paper view. Nine 9.3, solving equations using the quadratic formula. All right, so let's recall what the quadratic formula said. It says that if you have an equation of the form ax squared plus bx plus c equals 0, you need a 0 on the right-hand side, then the solution to this, or the solutions, are given by this formula. I say solutions because there's a plus or minus here. So there's actually a possibility of two solutions. If this stuff is not 0, right, then you're going to be adding or subtracting this number. When you add it, you get one solution. When you subtract it, you get another solution. Of course, if this is 0, you're adding or subtracting nothing, so you actually only have one solution. Right? So there's a possibility of one or two solutions when you use the quadratic formula. And we can see that's an interesting fact. Any second degree polynomial equation will have exactly one or two solutions. And that's what this is actually showing us. Those solutions might be complex numbers, right? If you take the square root of a negative number, we know that we get a complex number. So that is a possibility here. All right, so we're going to use this to solve some problems. I made note of some, and then I seem to have lost them. So give me a second to find where I may have put that sheet. No, there's some of them now. Sorry about this. I just misplaced problems that I had readied here. Oh, here they are. Okay, the last sheet I was looking at. Always in the last place you look. All right, so number 1, we want to solve. In all of these problems, we're going to solve. This equation. Right, well, it's just a matter of using that formula up here, right? So let's just apply it. So here we have the A, B, and C. A is 3, B is -5, and C is +2. Okay, so let's just plug that stuff in here. B is -5, so -5 is +5. B squared, that's -5 squared. It's 25. 4AC, that's 4 times 3 times 2. That is 24. Okay. Divide by 2A. A was 3. 2 times 3 is 6. So those are answers, but we can simplify this quite a bit. This is 5 plus or minus, well, 25 minus 24 is 1. The square root of 1 is 1. So we have two answers. We have 5 minus 1 over 6. That's 4/6. The other answer is 5 plus 1 over 6. That's 6/6. Of course, we can write that, we can simplify those, right? 4/6 is the same as 2/3, and 6/6 is the same as 1. So there are the possible values for x. In My Open Math, you'll have to write these separated by commas in the box. All right, so you'll write 2/3, comma 1. That's the preferred form of entry in the online homework. Okay. So just applying that formula, that's all we got to do. Let's do another one. Let's do y squared equals 15 plus 2y. Okay, well, for this problem, we don't yet have it in the form to which the equation applies, right? We need to have it in this form. And what is that form? Well, we have a 0 on the right-hand side. Okay, so that's not yet like that. So we need to manipulate this equation a little bit using algebra so that there's a 0 on the right-hand side. So let's do that. So I'm going to subtract 2y from both sides. So I get y squared minus 2y equals 15. Now to get 0, I'm going to subtract 15 from both sides. Okay, good. There it is. We got our 0. Now, now we can use the quadratic formula. Okay, there it is. We need to know what a, b, and c are, and then we just plug those in here. Well, let's look at this. A is the coefficient in front of the variable that's squared. So a is 1. Right? B is the coefficient in front of the variable. So that's a negative 2. And c is the last value that you have that's being added without a variable. So c is negative 15. So a is 1, b is negative 2, c is negative 15. So in this case, the variable is y, so I'm going to write y equals, and let's look back up at our formula. It's negative b, so it's negative negative 2, so that's positive 2, plus or minus the square root of b squared, all right? So b squared is the negative 2 squared, so that's 4, minus 4 times a times c. So it's going to be 4 times 1 times negative 15. 4 times 1 is 4, and 4 times negative 15 is negative 60. Okay. And then we divide by 2a. So the a was 1, 2 times 1 is 2. So there we have it. Okay, so this is equal to 2 plus or minus, well, look at this, 4 minus negative 60. That's the same thing as 4 plus positive 60. That's 64, right? The square root of 64 is 8. Four minus negative 60 is 4 plus positive 60. And so remember, subtracting a number is the same thing as adding the opposite. So that gives 64, and the square root of 64 is 8. Okay? So when I add 8, I get, well, let's do the subtract. We did subtract first last time. Let's do that the same. If I subtract 8, I get negative 6 over 2. If I add 8, I get 10 over 2. So I'm getting 2 answers here. I'm getting negative 3, and I'm also getting 5. So y could be either one of those, and they would solve this equation. All right. So let's look at another one. Let's try to leave that up there in case you're still copying it down. All right. So the next one will be the answer to this one is going to be a little bit more complex. I don't know if it'll be a complex number, but it'll be a little bit more sophisticated, maybe. All right, so here we have 3m squared plus 12m plus 7 equals 0. Well, fortunately, it's already got equals 0, so I don't have to do that stuff that I did up here, right? It's already set equal to 0, so we're good to go. I know that m is equal to, remember, it's negative b, so it's negative 12 plus or minus the square root of b squared, so 12 squared, that's 144, minus 4 times a times c. Now, maybe I shouldn't have written the, I think we can just, well, no, maybe I'll write it down because it's a more complicated thing to multiply out. 4 times a times c, 4 times 3 times 7. And then we're going to divide by 2a, 2 times 3. Okay. All right, well, yeah, what is 4 times 3 times 7? Well, that's 12 times 7. That's 84, right? 12 times 7, 84. So 144 minus 84 is 60. So, okay. Unfortunately, unlike the last problems, 60 isn't, let me adjust the camera a little bit. 60 isn't a perfect square. So it's not going to come out as nice as before, but it is something we can simplify. All right, let's do that on the side here. What's the square root of 60? Can we simplify that? Well, can we factor out a perfect square? Well, yeah, it's divisible by 4, right? So root 60 is root 4 times 15. And I know what the square root of 4 is, it's 2. So that's 2 root 15. And 15 doesn't have any perfect square factors, so that's as good as we can get here. Okay, so that's what we're going to put in there. In place of 60, we're going to write 2 root 15. All right, we can simplify this a little bit more because you see the numerator and denominator are divisible by 2. All right, so we can kind of simplify this by dividing the numerator and denominator by 2. So let's do that. Okay. Negative 12 divided by 2 is negative 6. 2 divided by 2 is 1. So I'm just left with root 15. 6 divided by 2 is 3. Okay, so that's one way to write the answer. You could just write it like this. Okay, that's a common way to write this kind of answer. Or you could write it like this. You could write down the two answers individually. Negative 6 minus root 15 over 3. And then put an or here. And then negative 6 plus root 15 over 3. So in my open math, you're going to want to write the two answers separately because there's no plus or minus button. All right, so you're going to have to write it like this. And you'll separate these by commas. And this is as simple as we can write it because unfortunately, root 15 can't be simplified anymore. So this is as good as we can get. And I want to caution everybody not to make the mistake of trying to cancel the 3 and the 6. Can't do that. I'm not allowed. All right. Same reason why I didn't just factor the 6, cancel the 6 here. Can't do that because you have to do it from every term in the numerator. They're being added or subtracted. All right. So what I did do is divide the numerator and denominator by 2. But when I divided by 2, I divided both of these by 2, right? Not just one of them. So you can't just cancel the 3 with the 6 and ignore the root 15, right? If it doesn't go into there evenly, you can't do that. So this is as simple as it gets. This is fully simplified. All right. Let's look at a couple more, and then we'll move on to the application problems, okay? This one is 5b squared plus 2b plus 4 equals 0. Now this one's going to be a little bit confusing to talk about because it's got the letter b as a variable, even though we were using the letter b to denote the coefficient in front of the variable, right? So it might be a little bit confusing here. We have to keep those straight. So don't get that b confused with this b. We're using the same letter here. We happen to use the same letter here for something else, all right? The b in this formula corresponds to the 2, the number in front of the variable. So we have to be a little bit cautious here about how we approach this, but just treat it the same way. All right, so the variable here is b. So the quadratic formula tells us that b is equal to negative the coefficient in front of the variable, that, plus or minus the square root of that coefficient squared, minus 4 times this, all right? 4 times 5 times 4. Well, let's see, 4 times 5 is 20, and 20 times 4 is 80, right? 4 times 5 times 4. That was the 4AC part, right? Okay, and so we divide by twice this number. That's 10 in this case. So here we have essentially our answer. We just need to simplify it. What's 4 minus 80? Well, that's negative 76. All right, well, let's simplify root negative 76. We're running out of space, so I'm going to go way up here. All right, and we'll simplify that. Root negative 76. Well, we know that when we have a negative inside the square root, it comes out as I. So this is root 76 times I. Okay, so this is going to be a complex number, an imaginary number here. Now, can I factor out a perfect square here? Can I simplify this? Well, let's see. 76 is divisible by 2. In fact, it's exactly twice 38. And 38 is divisible by 2. So that means it's divisible by 4. It's 19 times 4. And 19 is a prime number, so that's as good as I can do. So I can write this as 4 times 19 under the square root. And the square root of 4, just like we did up here, is 2. So it's 2 root 19I. That's what root negative 76 is. All right? 2 root 19I. So that is what we're going to put in place of here. So let's go up here. B is equal to negative 2 plus or minus 2 root 19I over 10. Now I'm seeing that everything here is divisible by 2, so we can simplify everything by dividing it by 2, just like we did in the previous problem. Negative 2 divided by 2 is negative 1. 2 divided by 2 is 1, so I'm just left with the root 19i there. And in the bottom, I have 5. Okay, so that is the answer, and a lot of times people will write it like that, but on My Open Math, they want you to write the individual answers separately. So we're going to take the two answers. The negative one where we subtract, that's negative 1 minus root 19i over 5. And then the other answer is negative 1 plus root 19i over 5. So those are our two answers. Excuse the mess below here. Just ignore that. So that is our final answer. Okay. Get two complex solutions. All right. One more problem here before we do the applications. I can find a, hold on, give me 1 second. I got to find a sheet. Okay. Alrighty, so for this next problem, maybe I'll leave this up here in case you're still looking. I'm not going to do this one completely. I just want to show you how to start it. I want to get to these application problems. All right. In this problem, which I'm calling number 5, we need to solve this equation. Well, just like the previous problems, we need to get it in the form of a polynomial equal to 0. So yeah, subtract 5 from both sides, right? So I have x times x plus 2 minus 5 equals 0. Okay, that's good. I got it equal to 0. Fantastic. But it's not of the form that we need, right? It's not written like this. It's not ax squared plus bx plus c. It's not expanded out like this, all right? So that's what we have to do. We have to expand it out. So I've got to multiply through here. What's x times x plus 2? X squared plus 2x. Now it's of the form. A, it's 1x squared plus 2x minus 5. So A is 1, B is 2, C is negative 5. Right? So now you can use the quadratic formula, right? X is equal to negative b plus or minus the square root of b squared minus 4 times 1 times negative 5. So 4 times 1 is 4 times negative 5 is negative 20. Be a little careful here with the double negatives. Make sure you keep those straight. Over 2 times a. Well, a here is 1, so it's just over 2. Okay? So I'll let you think about what the answer is for that one. It won't be a complex number, but I think we've done enough examples here where you can take it from here, right? It's very similar to some of the other problems we did. What I just wanted to point out is how you handle something like this. Sometimes you're going to have to multiply everything out so that you can get it into this form. So just keep that in mind, okay? All righty. So that was section was it 9.3, okay? So now what we're going to do is we're going to look at application problems, okay? So I have a few here. So application problems, we're going to use these techniques that we learned to solve these polynomial equations so that we can solve some problems described in words, all right? Some problems that you might imagine could actually occur in real life, all right? So this is going to be section 9.5. So I'm gonna, are there any questions before I do that?
Yeah. How did it come 20 to SC?
Oh, in the last problem.
Yeah.
Okay, so I'll look at that one and then we'll go to section 9.5. Okay. So in this problem, the question was, how did it come to minus 20 here? So remember the formula. The formula is ax squared plus, oh, sorry, is it? Underneath the radical, we have b squared minus 4ac. And you might hear, sometimes people talk about this, they call it the...
Oh, I understand. I thought this is 2 SC.
Oh,
Thank
okay.
you.
They call this the discriminant. So you might see that terminology used sometimes. So the discriminant is just b squared minus 4ac. By looking at the discriminant, you can tell if there's going to be one solution, two solutions, and whether the solutions are complex. So sometimes what people do is they immediately just look at this. They just compute b squared minus 4ac, just to get an idea of what kind of solutions to expect in a problem. But anyway, to your question, yeah, it looks like you figured it out. B squared minus 4ac is b is 2, so 2 squared is 4, minus 4 times 1 times negative 5. 4 times 1 is 4, times negative 5 is negative 20. So we're subtracting 4ac, subtracting negative 20, and I forgot my right parentheses there. So I'm glad you pointed that out, because I should have written that. Okay, any other questions? Yeah, I don't always see the chat, so make sure it doesn't chime or anything when you send the chat. So you may need to use your mic if you have a question. I don't see it right away. Okay, so next section. Last thing we'll talk about today is applications. So we're just going to use what we learned here to solve some word problems. Okay, so in this first word problem, it has to do with finding the base and height of a triangle. Okay, so they're telling us here that, try to straighten this a little bit. Okay. The base and height of a triangle whose base is 4 inches more than 6 times its width has an area of 465 square inches. Let's just draw a triangle here. Okay. It has a base, right? Let's call that B. Its height is H. Let's call that H. How do we compute the area of a triangle? Well, you might remember this formula. If you forgot the formula, just remember that a triangle is well, never mind. You remember the formula. So the area is 1/2 base times height. I have to conserve paper here, so I have to be careful. You can look this up. The derivation for this is not too bad. It's 1/2 base times height. Okay. So let's look at the problem that we've got. The base is 4 inches more than. Okay, so the base is 4 more than, so 4 plus, 6 times the height, 6 times h. Okay, base is 4 plus 6h. And the area is 465. We also know that area is 56. Okay, so we're just going to plug this stuff in up there. Okay, so the area is 456. Rewriting this equation equals 1/2. The base is 4 plus 6h. And the height I'm just calling h. So look, we got an equation in terms of a single variable. That's fantastic, because that's the type of equation that we've been dealing with. An equations in terms of a single variable, we've been solving these. So let's try to solve this. Well, on the right-hand side here, I see that if I multiply through by h, I'll get an h squared. So this will become a polynomial, right? I'm not liking this 1/4 though. I don't really want fractions in my problem. So maybe the very first thing I should do is to multiply both sides by 4. Okay? So multiply both sides by 4. All right. Let me just use a calculator to do this quickly. What's 456 times 4? Let's see. 1,824. 1824. And on the right-hand side, the 4 and the 1/4 cancel off. All right. So I just got 4 plus 6h times h. Okay. And I can turn this into a problem similar to the ones that we've been solving if I distribute the h through. So 1824 equals 4h plus 6h squared. Now it's looking good. I know how to solve this if I can get a 0 on one side, right? So if I subtract 1824 from both sides, I get a 0. Let me write this in order that we had before. So instead of writing 4h plus 6h squared, I'm going to write 6h squared plus 4h. Same thing. A plus b is the same as b plus a. And then what did I do? I subtracted 1824 from both sides. So I've got a polynomial equal to 0. So I can use the quadratic formula here. So let's use the quadratic formula. So let me get another sheet here. I'm running out of space on this problem. So what happens here? Well, we know that h is equal to, well, let's see. Here's the a, b, and c. So it's negative b, so negative 4 plus or minus square root of b squared minus 4 times a times c. So 4 times 6 times 1824, big number, but we can do it. I'll do that on a calculator. So 4 times 6 times 1824, whew, 43,776. Okay. Oh, I made one mistake. See if you can spot it.
It should be plus.
Yes, very good, very good. Yeah, remember it's 4ac. C is negative, and we're subtracting 4ac. So if you subtract a negative number, it's the same as adding. Yeah, so good job. Minus 4, 6 times negative this makes a positive. Okay, divide by twice a. So 2 times 6, 12. All right, well, hopefully 43,776 plus 16 is not too bad. Let's see what we get. I'm going to add 16 to that. All right. Ooh, it's not a perfect square. That's unfortunate. Okay. Let's see here. So when I add 16 to that, I get 43,792. All right, we got some work to do to simplify this radical. All right, so let's see what we can do here. Let's see. Okay, so I got to see if there's perfect squares in this. Okay. So 43,792. Well, I know that if I factor out a 2, I know it's divisible by 2 because it's an even number. It ends in 2. So 43,792 divided by 2 is 21,896. Right? And that's divisible by 2. All right, fantastic. So factor out another 2. So divide that by 2. All right, 10,948. That's divisible by 2 because it ends in an even number. So factor out a 2 again. So divide that by 2. 5,474. That's even. So divide that by 2. If I see it's even, that's what I do. I just keep dividing by 2. Factor out all the 2's I can. And that is this. Okay, now that's not even. So I see here that I can pull some 2's out, right? So that's good. What can we do with this? Let's see, maybe that's divisible by 3? No. It's not divisible by 4 because it's not even. It's not divisible by 5 because it doesn't end in a 5 or 0. It's divisible. I checked it. I just divided by 7 to see what happened. And sure enough, it's divisible by 7. All right. And now what about 391? Can I factor 391 anymore? Let's see. Can I get anything out of there? Well, I know it's not divisible by 2. I already tried 3. 5, no. 4, no. So that's 6, no, because it's not even. 7, no. Yeah. Oh, okay. All right, it's divisible by 17 and 23. All right, so 7. Let me just check that. 17 times 23. That's not obvious, but if you keep checking, you'll see. Yeah. Okay. So I've completely factored that down into its prime decomposition. That's what they call that. These are all prime numbers. They can't be factored anymore. So what we're looking for when we simplify a radical, we're looking for something that occurs an even number of times. And so 2 does. In fact, this is 2 to the 4th right here. So it's 2 to the 4th times this stuff. Nothing useful came out of that. So I'll just do 2 to the 4th times this. All right, so it's -4 plus or minus 2 to the 4th times 2737 over 12. But if I take square root of 2 to the 4th, I cut the exponent in half. Right, so 2 to the 4th comes out as 2 squared. So it's -4 plus or minus 2 squared is 4. All right. So if I was, oh, and I can simplify this a little bit more because everything's divisible by 4. So divide everything by 4. And what do I get? I get -1. 4 divided by 4 is -1 plus or minus 2737 over 3. Okay. Good. We got 2 answers there. -1 minus this and -1 plus this over 3. Okay, let's go back to the problem here. All right. So we're looking, what we were finding here was h. H represents the height, right? So let's look at these 2 answers. If I take -1 and subtract this positive number, I get a negative number. Can the height of a triangle ever be negative? No. So while I got 2 solutions here, only one of them makes sense. All right, only the one where I'm adding the root 2737. The other one gives me a negative height, and that's not possible. All right, so in fact, what we see here is that the height is only one of those 2 solutions. The only one that makes sense is -1 plus root 2737 over 3. Okay? I'm going to write this as a decimal because I think this is, all these radicals and stuff are getting out of hand. They're probably going to want this as a decimal anyway. So let me, and if we did it that way, we probably didn't have to go through all that trouble factoring everything. I just thought maybe it would turn out nice, so it's worth doing. 2737 square root, and then I'm adding -1 to it, and then dividing by 3. 17.11. Okay. Yeah, 17.11. Don't need that work anymore. Okay, they wanted the dimensions. They want the base and the height. So we found the height, now we have to find the base. Well, how do we get that? Well, check this out. We have a little formula right there. So if I just take this answer and plug it into this formula, I get the base. The base is equal to, so I'll just take that answer I just got, multiply it by 6, add 4, and I get, is that right? Yeah, that looks right. 106.63 approximately, because I'm rounding here. Okay. So there we go. Some big numbers to deal with there. I probably should have just used a calculator earlier on, but maybe that was a good exercise in how to simplify a big radical anyway. Okay. So let's do one more. Okay. Here we have the sun casts a shadow from a flagpole. The height of the flagpole is 3 times the length of its shadow. Let me just draw a picture of this. We have this flagpole, and the shadow is just 1/3 the height. All right, so we have this. The distance between the end of the shadow and the top of the flagpole, that's this distance, is 20 feet. Find the length of the shadow and the length of the flagpole. So, all right, well, let's say the length of the shadow is X and the length of the flagpole is Y. Okay? So X equals length of shadow, Y equals length of the pole. Okay? Now, let's see what information we have here. Let's go back to the beginning of the problem. Okay, the height of the flagpole is 3 times the length of its shadow. We haven't used this yet. The height is, well, the height is what I'm given by, that's what I'm saying Y is. So Y is 3 times 3 multiplied by the length of its shadow. Well, the length of its shadow is X. So it's just 3X. Okay, so I can express Y in terms of X. That's nice. And then the distance. Okay. How am I going to incorporate that? Well, look at the picture. Look at the picture here. I've got a right triangle. Okay. And so, do you know a equation that relates the sides of a right triangle? Well, you should. What should pop to mind is the Pythagorean equation. Okay. Or the Pythagorean formula, is that what they usually call it? The Pythagorean formula says that if you have a triangle with sides length A, B, and C, that the hypotenuse squared is equal to A squared plus B squared. Okay. A well-known formula from geometry. Okay, so I think we can use that here because we got three sides of a right triangle, and we're talking about the length, so I think that works. So let's go ahead and use this formula up in this problem. What's the hypotenuse of this triangle? Well, it's 20, so c squared is going to be 20 squared. So if I just take this formula out, 20 squared is 400. A squared is the bottom, so that's going to be x squared. And then b squared is the height squared. And so it's 400 equals x squared plus y squared. But we know that y is 3x. All right, so let's substitute that in. I want to do that because every equation that we've been solving has only one variable in it, right? So I don't want there to be two. So if I can eliminate one in favor of the other one, let's do it, right? So that's what I just did. So let's write this out some more. Let's say this is x squared plus 9x squared. So that's 10x squared. All right, so I'll just divide both sides by 10. So I get 40 equals x squared. All right. Well, okay, I know how to solve this. I don't need the quadratic equation or anything like that for this one. I mean, this is just a very simple problem. We know that x is equal to plus or minus root 40. All right. However, x is the length of the shadow. So does negative root 40 make sense? No. You can't have a negative length. So we ignore the negative solution in this particular case, and we only deal with the positive solution. So we know that x is equal to positive root 40. Of course, we can simplify root 40. Let me just do that on a separate sheet over here. All right. Square root of 40 is the square root of 4 times 10. Square root of 4 is 2, so it's 2 root 10. Okay. So that's what I would write here, 2 root 10. Except that they wanted us to round to the nearest tenth. So I guess they do want us to use a calculator for this. So 2 times 10 square root 10, 6.32. If I round to the nearest tenth, that rounds to 6.3. And these are measured in feet. I don't really have room to write that, feet. All right. That's the length of what? They wanted two things here. They wanted the length of the shadow and the length of the flagpole. So we got the length of, what does x represent? X is the length of the shadow, right? So we got the length of the shadow, 6.3 feet. How do we get the length of the pole? Well, let's look through our equations here, our work. Oh, look, this relates the length of the pole to the length of the shadow. It says the length of the pole is 3 times the length of the shadow. So we just have to multiply that by 3. Don't need a calculator for that. 18.9. So there we have the final answer. Okay. So some application problems. We needed to learn, we needed to use the area of a triangle here, 1/2 base times height. We needed to use the Pythagorean formula down here. Some of these problems will involve the area of a rectangle, so that's something you might need to look up. So if they talk about a geometric figure, you may need to go look up the formula for those things. But I think you can find those easily enough. And they're going to be using very basic geometry. Okay. So let me pull this back to my annoying face here. All right. So, are there any questions? Not seeing any. So, okay. All right. So, like I said, just another reminder: the exam's coming up. It's the Thursday. It's the Thursday after this week. So, it's let me just get the exact date again. April 30th. It covers chapters 8 and 9. Okay. We will have Tuesday of that week for review. All right. So this weekend, I'd like you to start thinking about problems. I'll post the copies of the homework so you can go review those, and that'll be the best thing you can do to review for the test is just go through the homeworks. Next Tuesday, we can just spend the time answering questions, reviewing for that exam. Okay. All right. So. All right, so let's call it quits for today, and I'll see you on Thursday when we will talk about graphing quadratic functions, so graphing polynomials. Okay. All right, so I'll